Okay, so first we'll do acceleration. Since that's easier to take derivative, we need a equals dv dt. So we'll put that here. We know a equals derivative of this, which would be 12t squared minus the 2 times 6 is also 12t. The derivative of that is minus 2. And then derivative of cosine is minus sine. But then because of chain rule, the 2 comes out. So we'll have 2 times 6, which is 12, sine of 2t. So if we plug in t equals 3, we know a of 3 equals 73.35 meters per second square. Then for position, we can use this one, v equals ds dt. So if we know that v equals ds dt, then we can rearrange. We get ds equals v dt. We need to integrate. So we start at t equals 0 and s equals 0. So here we go from 0 to t, and here we go from 0 to s. Because we need to find s, t is going to be given, and we're given here that they both start at 0. So that's how we get those bounds of integration. So then here we'll get s minus 0, which we can just scratch that off, equals integral of 4t cubed minus 6t squared minus 2t plus 6 cosine of 2t dt. This goes from 0 to t. That equals, so the integral of 4t cubed is just t to the 4 minus, this is going to be 2 times t cubed minus t squared plus 3 sine of 2t. This is evaluated from 0 to t. Okay, so this, here we use chain rule, so the way to check back at it, we do derivative of sine is cosine, and when you do chain rule on this, the 2 pops out, so you get 6 cosine of 2t. Okay, so all this is going to be from 0 to t, so we know that s equals t to the 4 minus 2t cubed minus t squared minus 3 sine of 2t. That's when we plug t in, and then when we plug 0 in, all of these go to 0 because sine of 0 is also 0. So this is our answer for s. So we plug the numbers in, we get s of 3 equals 17.16 meters. And then if you plug up here, v of 3, plug 3 into there, and you get 53.76 meters per second. Now if we look at a simulation of this, so that's what it looks like. And then we can see here, just to check if we plug in those numbers. So s of 0 is 0, that's correct. This point, 17.16, 53.76, and then 73.35. So we know that the answers we got were correct.